viewers, I am Tutor Sokoli. In today's class, we want to solve an exponential equation if 3 raised to the power x multiplied by 5 raised to the power x to the power of 2 is equal to 15. Then, what should be the value of x? Subscribe to my channel and also like my videos. Let us dive into this question. Solution to it. I am given to solve that 3 is raised to the power x multiplying 5 raised to the power x also raised to the power 2. Everything is equal to 15. I'll start from the right hand side by writing 15 as 3 multiplied by 5 equal to 3 raised to the power x multiplied by 5 raised to the power x raised to the power 2. But you also know that 3 is the same thing as 3 raised to the power 1 and the 5 is the same thing as 5 raised to the power 1. Okay, the next thing I will do, I will write 3 raised to the power x multiplied by 5 raised to the power x raised to the power 2. Here, I will divide by 3 raised to the power x multiplied by 3 raised to the power 1. I am dividing both sides now by 3 raised to the power x multiplied by 5 raised to the power 1. So this will now be equal to 3 raised to the power 1 multiplied by 5 raised to the power 1 divided by 3 raised to the power x multiplied by 5 raised to the power 1. I am dividing both sides of the equation by 3 raised to the power x multiplied by 5 raised to the power 1. And when that happens, you will see from the left hand side that 3 raised to the power x will cancel out 3 raised to the power x at the numerator and denominator respectively. And also from the right hand side, 5 raised to the power 1 at the denominator will cancel with the 5 raised to the power 1 at the numerator. So leaving me with 5 raised to the power x raised to the power 2 all over 5 raised to the power 1 equal to, by the right hand side I have left 3 raised to the power 1 all over 3 raised to the power x. I will now apply the law of indices that says that if I have a raised to the power x divided by a raised to the power y, it is equal to a raised to the power x minus y, provided the bases are the same. Okay? Therefore, if you look at this, the base at the numerator is 5 and the base at the denominator is 5. I will apply this law to have it as 5 raised to the power x raised to the power 2 minus 1. I've applied this law by the left hand side. I will also apply it to the right hand side because the bases are the same. The base at the numerator is 3, the base at the denominator is also 3. That means from the right hand side I will have 3 raised to the power 1 minus x. Very good. At this point I will apply the law log to both sides. I will apply logarithms to both sides. And that means the log of 5 raised to the power x raised to the power 2 minus 1 equal to the log of 3 raised to the power 1 minus x. By law of logarithms, if I give you log a, okay, raised to the power n, it is the same thing as n log a. What does that mean? The power will come to the front. So that is what I'm going to do here at the left hand side to have x raised to the power 2 minus 1, then log 5. And to the right hand side, I will do the same thing. The power here is 1 minus x. And that will give me 1 minus x, then log 3. Beautiful. The next thing I will do now is to divide both sides by logarithm of 5, log 5. And that means x raised to the power 2 minus 1, okay, log 5 divided by log 5 is equal to 1 minus x into the logarithm of 3 divided by the log of 5. So that log 5 will cancel out log 5 by the left hand side, leaving me with x raised to the power 2 minus 1 at the left hand side. And by the right hand side, what I have is 1 minus x then into the log of 3, okay, divided by the log of 5. But by what we call change of base, in laws of log building. If I have the log of A, okay, maybe to base B divided by the log of C to base B. Very good. This is the same thing as equal to the logarithm of A, okay, base C. Very good. Base C. All right. What does it mean? When the bases are the same, we can have a change of base in the logarithms. This is log 3 base 10, log 5 base 10. So we can change it to write it now as, from here, x, okay, let's break it down a bit. X raised to the power 2 minus 1 equal to 1 minus x, then the logarithm of 3 base 5. Applying change of logarithm, okay, change of base in logarithms. Now, what will I do next? Let me move everything I have by the right hand side to the left hand side so that I will have what is like this, x raised to the power 2 minus 1. Then this one coming over will be minus, then 1 minus x, then log 3 base 5 equal to 0. Let me make space on the board. Alright, so this now will be equal to 0. It is now very perfect. We move on. What will I do next? Let me open this bracket. And when I open this bracket, I will get x raised to the power 2 minus 1. Then opening this bracket will give me minus, that is minus times minus x will give me minus x. Then minus times 1, that is minus times minus x will give me plus x. Then minus times 1 will give me minus 1. Then the log of 3 base 5 equal to 0. At this point, I want to represent this alone as difference of two squares. That means x raised to the power 2 minus 1 can be written as x minus 1 into x plus 1, then x minus 1 logarithm of 3 base 5 equal to 0. Why did I apply this? The law of difference of two squares says a raised to the power b2 plus b raised to the power 2 is the same thing, or I put it like this, yeah, it's the same thing as a plus b, okay, into a minus b. This is what we call difference of two squares, and that's exactly what I have here. Because this x raised to the power 2 minus 1 can also be written as 1 raised to the power 2, okay? So if 1 can be written as 1 raised to the power 2, therefore it is difference of two squares, so it takes the nature of a squared plus b squared, which can be expressed as a plus b into a minus b, and that is exactly what I have written down. Okay, of course you know that multiplication is commutative, meaning that this can come first and this coming second, both of them are the same. Okay, now something is common, and what is common? Please, I beg your pardon, there is plus here, so there is plus here, plus, then x minus 1, very good. This plus is omitted, so I've put it back. Very important, all right? Plus x minus 1. So I just wrote into x minus 1. Then inserting back the plus, you will now see with me that x minus 1 is common. So I write x minus 1 into the bracket x plus 1. Then log, that is x minus 1 outside. Here I have x plus 1. Then leaving me here with a plus the log of 3 base 5. Everything now is equal to 0. Okay. So what does this mean? It means that the first bracket is equal to 0 and the second bracket is equal to 0. So I now write x minus 1 equal to 0, implying that x is equal to 1. First value of x is out. From the second bracket, x plus 1 plus log. So x plus 1 plus log 3 base 5, which means x is equal to minus 1 minus log 3 base 5. Meaning that the value of x also here is equal to minus into 1 plus log 3 base 5. Very good. So that is the second value. But then, we can change this place, which is 1, to be in the same base with this. So 1 is the same thing. Note that log a base a is equal to 1. Meaning I can write here as x equal to minus log 5 base 5 plus log 3 base 5. And this is going to give me my final answer as, watch out, from here I can now have it written as x equal to minus log 5 base 5 plus log 3 base 5. I can now multiply the two to have it as 5 times 3, which is log 15 base 5. Very correct. So, in conclusion, the two answers we have for x. The first one is 1, x equal to 1. And the second answer is minus into log 15, okay, base 5. That is the second answer. Minus log 15 base 5. Why? Because in logarithms, we have it that if log a base b plus log c base b is given to me, it is the same thing as log a times b. So it is equal to log a c then base b. This is a law in logarithm. So going by this law, that is why here when I got log 5 base 5 plus log 3 base 5, I simply multiplied log 5 base 5 by log 3 base 5 to give me 5 times 3, which is log 15 to the same base. It is this law that guided me into getting this final answer, which is negative log 15 base 5. Thank you, dear friends, for watching to the end. Subscribe to my channel and also like my videos.